I need checks to remember to use the good mics and the good cams. Okay, so what I have going on right now is actually 2 simultaneous streams. And the idea here is going to be this main... Oh, I want to do a test too. Let's see. If I click record... See, why is there a card error? I don't understand. Like, there's a... Okay, what happens if I just do this? And then I put it back in. I don't get it. Okay, hold on. Now I gotta debug something. Alright, so let's just... Okay, so... That's so annoying. Come on, show up. Show up. Oh, there we go. I'm noticing... Oh my god. You can't be serious. Hello? I'm noticing that on my Nikon D7100, I have set up with it one of those USB-C HDMI capture card things to my... But what I've noticed is that when it's not plugged in, I don't get a card read error. Oh wait, actually, hold on. Okay, card read error. Let me take out all of those, then plug back in the SD cards. Okay, and now there's no card read error. But now if I plug in the USB, or if I plug in the HDMI rather, okay, I don't have a card read error anymore. Okay, good. Never mind. So let's try that. So hold on. So I'll just do this. Okay, but so let's just see if I can actually get this to work. All right, so we have, okay, and now I'm gonna record. So let's see, record. So now I'm recording, and I'm filming. Okay, so that's perfect, because one thing that I noticed yesterday that was driving me absolutely crazy is I had this totally gorgeous shot of the piperine solution cooling down, and I noticed that I was getting like frame drops, like I was losing, like it looked jittery, and oh, it made me so sad because it was so beautiful in person, and the playback footage was terrible. Okay, so I'm gonna get my protective equipment on, and then it's time to do the stuff. I need to get some ice too. All right, so that is the piperine solution, and that's what's happening. What's up? Yeah, I'm gonna call her. Actually, I'm gonna call her. Okay, I'm back and I'm ready to do this thing. So, get some socks on, and so this is gonna be pretty fun, I think. Oh, one thing that I never set up, but actually I'm not gonna do it. I don't think I need it, but I'll explain the setup in a second. Oh, I need to get some ice. Okay. Oh wait, hold on. Hello. Okay, alright. Sorry. Ay, ay, ay. Hopefully I had backup mic. The other chat should have the backup on it. How's the picture quality? Is it good or is it out of focus? Okay, now it looks a little bit better. Alright, so I'm just plugging away at this thing. How do I view the chat? Okay, alright. The audio quality should be good now. I might get the fan out. This thing smells bad. I'm not sure what that is though, but something smells bad. I don't like that, man. Hey, yo, Mr. White. Hey, Google. Is it acceptable to agitate a filter paper while doing a vacuum filtration? Bro. No, it didn't even answer my phone. Am I allowed to? I'm doing a vacuum filtration of piperine right now, and I'm wondering, is it allowed to agitate the filter paper by using a scraper to potentially, I don't know, speed up the, is that allowed?
Let me check that. Generally, you don't want to scrape the filter paper directly. That can tear it or force fine particles through. If flow is slow, you can gently swirl the slurry or lightly break up just the top of the cake without touching the paper. If you're drying the crystals, you can just leave the vacuum on for a few extra minutes. How slow is it? Is it just a trickle or basically stop?
There's like a bunch of foam coming through it. I don't know, so like a small amount of foam is trickling through the.
Yeah. Small amount of foaming isn't unusual, especially if there are soap-like residues or a little dissolved gas coming out. Where's the foam showing up? Above the filter or in the flask below?
In the flask below.
Okay, one moment. If it's in the flask below, that's actually a bit reassuring. It just means the filtrate is splashing and outgassing a bit under vacuum. Given you used NaO8 earlier, trace soap-like stuff can definitely make a little foam. So usually it's not a problem, as long as it's not getting sucked into the vacuum pipe. If the foam starts climbing towards the sidearm, just ease off the vacuum a bit or pause briefly. What color is the foam? Is it white or yellowish?
Yellow. Yellow green.
Let me check. Yeah, yellow-green just means it's carrying a little of your piperine solution. Not a big deal by itself. Keep an eye on the level though. If it starts creeping toward the sidearm, just back off the vacuum. Is it staying put or building?
No, it's very small. It's not even close to the exit.
Perfect. Then you should be fine continuing as is. Just keep an eye on it. If it starts to rise, ease off the vacuum and use that trap if you set it up. Otherwise, carry on.
I didn't set up the trap because I couldn't figure out how to use it. But I don't think I need it really.
Let me check that. With a little hand pop, it's not critical, but the trap's cheap insurance. I'd use it next time once you figure out the tubing. But for now, with the low foam you got, carry on.
Okay. What about some Factoria? Uh, I have to finish this and then I'm super down. But how are you gonna stay up late? Cause this is gonna take me a while. Cause I have to do the recrystallization. Oh wait, let me end my fucking. I have to end my call with Chat GPT. It's looking like it's getting dry, baby. That's my crude, man. Okay, now I have my ice water, and the idea is to wash it. You're running out of Claude tokens? Dude, that's always the worst feeling. I feel like I didn't get that much product. Let me read the instructions again. I feel like it's leaking. Like I might be just losing everything. I can't tell. You said I have a gram. I have like 5 milligrams. There is a distinctly. It does smell a little bit like black pepper, but like mixed with something maybe. Okay, so I. All right. All right. So. So what do I do? But see, this is what I don't like. Like, did I just ruin this thing? Okay, I also see that the glass fritted, the 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 glass filter itself is now super orange. And did I just destroy this filter? I mean, it's glass. How am I supposed to clean this? Oh wait. Oh fuck. Oh shit. How did that thing get dirty? What? Oh, that's cleaning it up actually. Let me get my scale. Where's the scale? I don't know, is it supposed to look like this? Let me watch a video, because I feel like I messed it up. But I don't know how I messed it up so bad. I feel like this filtrate though. I feel like it's. I mean, now it's got a bunch of junk in it, but presumably it already had a bunch of junk in it. Okay, so I'm gonna get the pH paper and test the pH of the filtrate. But I feel like this thing is a terrible design because the thing though is I mean just conceptually, shouldn't the filter paper have smaller pores than the frit? I mean, doesn't that just kind of make sense? Because then this problem basically can't arise. Um, right, let me watch a video. That's what I get for it going so well yesterday, or at least seemingly. First, the now red one. Look at those crystals. Those are beautiful, man. I want that.
Okay, so this is a new series called Edible Chem, where I'll be using only food-grade supplies and clean glassware. At the end, I should be able to taste or eat what I make. The purpose of the series is to explore the production of some of the chemicals that are used in our foods and as supplements. Even though the stuff that I produce should be food-grade, this video should be treated as entertainment purposes only, and I really don't encourage anyone to recreate what they see. If you make a mistake, you could potentially poison yourself. Anyway, with the disclaimer done, we can move on to the actual video. Piperine and its isomer chavasine are responsible for the spiciness of black pepper. It works by acting on the protein receptors TRPV1 and TRPV2, which normally sense heat. These receptors are found in nerve cells, and when they're bound and activated by piperine, it tricks the brain into thinking it's sensing heat. Piperine isn't the only molecule that does this, and there's two other major ones, which are actually the one potent: capsaicin and allyl-isothiocyanate. Capsaicin is found in chili peppers, and allyl-isothiocyanate is found in horseradish and wasabi. I plan to make a video on each of these sometime in the future. Another interesting thing about piperine is that it can inhibit the breakdown of certain xenobiotics. Xenobiotics are basically just molecules that don't occur naturally in your body, and it's most often referring to things like drugs or pollutants. So if piperine is ingested, it can inhibit the breakdown of certain things and make them more effective. A good example of this is curcumin, which is found in turmeric. Explain exactly how it works later in the grinder. It's important that the isopropyl alcohol are alcohol.
Maybe I didn't run the extraction long enough.
Video. In terms of supplies, I just needed three things: the pepper itself, potassium hydroxide, and isopropyl alcohol. Both the potassium hydroxide and the isopropyl alcohol are food grade. The first thing that I need to do is crush the pepper, so I use a coffee grinder. It's important not to crush it too much though, because if the powder is too fine, the sawtooth extractor isn't going to drain properly.
He ran it for.
I thought I could get away with crushing it to a fine powder like you see here, but it ended up being a total failure. What you really want is something like this, which is the
Okay, alright, so that's pretty close to what I had.
But before we move on, it might be a good idea to pass the powder through something like a strainer to get rid of the larger pieces. I set up the sawtooth extractor and I slide a few pieces of cotton to the bottom. At the bottom of the extraction chamber, there's a hole that leads to the siphon.
Oh, look at those big. Look at those.
It's also important not to pack the
Whatever,
cotton,
mine worked
otherwise it
perfectly.
won't drain properly. Once the cotton has been placed, I pour in the chopped up pepper. I then place another cotton ball on top. I add a condenser above the extractor and I turn on the water pump. This entire apparatus is then attached to a flask that's being loaded with isopropyl alcohol. I set up a stir plate at the heating mantle and I'm pretty much ready to get things started. The heating stirring is turned on and I bring the alcohol to a boil. As the alcohol boils, you can see the hot vapor traveling up and condensing on the walls of the glass. The hot vapor will slowly travel up the glass and it will eventually make it to the top. When it does, it goes into the condenser, which turns it back to a liquid. The now liquid, but still hot isopropyl alcohol, is dripped onto the pepper. As the process continues, the extraction chamber will slowly fill up with alcohol. I've turned the extractor to the side so you can get a better idea as to what's going on. As the extraction chamber is filled with solvent, some of the liquid is pushed out through the bottom and into the siphon tube. The level of solvent in the siphon should be about the same as the level in the extraction chamber. As more solvent is added, the level will continue to rise until it eventually gets to the top of the tube. Once it gets past the bend, gravity will take over and all of the solvent will be drained from the extraction chamber. All of the solvent is dumped into the flask below with the rest of the alcohol. This marks the end of one cycle, and in theory you can cycle it as many times as you want. For this extraction, I'm only going to do it for 2 hours, but there are preparations that require several hours or even days. So at this point, you can see why the sawtooth extractor is so useful. It basically allows us to do repeated hot solvent extractions using a relatively small amount of solvent. If I didn't have a saw sled, I could just boil the hot pepper in a whole bunch of isopropyl, or do manual repeated hot solvent extractions. Both of these options require more solvent, and the second one can be a lot of work. So 2 hours later, I was left with this yellowish brown liquid. The solution contains piperine, but it also has a bunch of other stuff that was extracted along with it. This includes things like fats, as well as anything that's soluble in hot isopropyl. A little bit of the pepper made it past the cotton, so before moving on, I need to quickly filter it. I packed the cotton ball into a funnel, and I filtered it through. Once everything passed through, I washed the round bottom and the funnel with a little bit of warm isopropyl. I took away the funnel, and I added magnetic stir bars to the last. I now need to get rid of most of the isopropyl, and to do this, I use a simple distillation. In the meantime, I prepare a base solution by dissolving about 1 gram of potassium hydroxide in 10 milliliters of isopropyl.
1 gram? Okay, that's. But I think because the molar mass of potassium hydroxide is higher, then the amount of actual hydroxide is probably comparable.
And it doesn't really dissolve very well. To speed things up, I heated it a few times using the microwave. Eventually, the big chunks are gone, and this is pretty much good enough. Once I had about 15 milliliters left in the flask, I stopped the distillation. I then added the potassium hydroxide solution to the stuff that remained. When the potassium hydroxide is added, it reacts with acids as well as some fats that were extracted along with the piperine. This will convert into something that's soluble in water, so in the next step, when we add water to crash out piperine, these things don't come out with it. It also allegedly reacts with the chapsine, but I couldn't find a good source to support this. So after about an hour, I take it off the stand, and there's quite a bit of solid stuff. This is very easily removed by just passing it through a little bit of cotton. The cotton in the flask are washed a few times with a little bit of isopropanol. The funnel is removed, and now it's time to isolate the piperine. To do this, I just need to add some water. Piperine is really insoluble in water, so adding even a small amount greatly reduces its solubility. Every time water is added, we can see a cloud of piperine crashing out. Eventually, when water is added, it doesn't look like piperine is crashing out, and at this point we're done. The beef is then placed in the fridge for a few days to allow the piperine to fully precipitate. In the meantime, I start to clean things up, and I empty out all of the pepper from my sauce extractor. It's still wet with isopropyl alcohol, but I'm going to wait a few days for it to fully dry out. A couple days later, I take my piperine out of the fridge, and it's time to filter it off. I quickly look back to filtration and then let the batch run for a few minutes to dry things up. Using a spatula, I scrape the piperine off the filter, and I'm left with paste. One thing to note is that some of the piperine is super fine, and it's not able to be trapped by the filter. It might look like a lot, but there actually isn't very much here. Everything is transferred to a small beaker, and I add some isopropanol. The hot filter turned on, and everything is dissolved. The initial amount of isopropanol I added was a bit too much, so I let some boil off. The beef is covered with plastic wrap, and I place it somewhere cool. It's really important that it goes down slowly, otherwise the crystals turn out pretty crappy. The crystallization is also really slow, and even once it gets to room temperature, no crystals form. Only after 10 minutes could anything start to form. The start of this time lapse is about 30 minutes after it already cooled to room temperature. The time lapse was taken for about an hour and a half, so in total it took around 2 hours for most of the crystals to form. I left it in the fridge, and this is what I had in the morning. The crystals were separated off the filter, and they were washed with a very small amount of ice-cold isopropyl alcohol. The filter was removed, and the isopropanol was allowed to evaporate. After a day or so, I was left with some nice and dry piperine crystals. My final recovery was about 1 gram. I extracted 23 grams of pepper, so this represents 4% of total mass. Black pepper typically contains between 5 and 9%, so this is pretty close. With piperine, it's actually possible to grow pretty big crystals, and the ones I have here are quite small. To get larger crystals, it needs to be crystallized over days or weeks, and not just hours. Anyway, now we move on to the taste test that I promised. Just before I do it though, remember this is for entertainment and educational purposes only, and you shouldn't do it yourself. Although piperine is a relatively common supplement sold in stores, it can interfere with certain drugs and be potentially dangerous. Okay, so here are the products of extraction. On the left here, I have pepper that I extracted from, which kind of looks washed out and lacking color. On the right here, I have the piperine, which is double crystallized and should be...
I mean, I guess I'm not doing anything. I guess I can just do it again.
It still definitely tastes like pepper. But...
So I think everything was fine. I probably didn't run it long enough, so I'll probably just like run it way longer. And then the main thing, then the distillation, that's fine. And if we look up piperine in Wikipedia, and then I don't know why he used IPA. Why did Now Red use IPA? Because it's like, anyways, it's probably soluble in both. I mean, they're both just small alcohols, so I imagine it's soluble in both.
In the meantime, I prepare a base solution by dissolving about 1 gram of potassium hydroxide in 10 milliliters of isopropanol. This takes quite a long time, and it doesn't really dissolve very well. To speed things up, I heated it a few times using a microwave. Eventually, the big chunks were gone, and this is pretty much good enough. Once I had about 15 milliliters left in the flask, I stopped the distillation. I then added the potassium hydroxide solution to the stuff that remained. When the potassium hydroxide is added, it reacts with acids as well as some fats that were extracted along with the piperine. This will convert them into something that's soluble in water, so in the next step, when we add water to crash out the piperine, these things don't come out with it. It also allegedly reacts with the chapsine, but I couldn't find a good source to support this. So after about an hour, I take it off the stand, and there's quite a bit of solid stuff. This is very easily removed by just passing it through a little bit of cotton. The cotton and the flask are washed a few times with a little bit of isopropanol. The funnel is removed, and now it's time to isolate the piperine. To do this, I just need to add some water. Piperine is really insoluble in water, so adding even a small amount greatly reduces its solubility. Every time water is added, we can see a cloud of piperine crashing out.
Alright, there's only one thing to do. Start over. I'm gonna say that was a total fail. What do I do with all this? It's like a water piperine solution. I guess I just put it in the waste bucket. Oh, gosh. Alright. I'm still going to use 40 grams because I want a lot. I want to know something though. So wait, where's the transcript again? Wait, why did they change this, dude? Why don't I have Pro anymore? I thought I have Pro. It's okay, Bob. This is how things go, man. This is how they go. The first time is always like a total failure. I mean, I think there's probably piperine in there, but like, just look how much he got. Look how much he got. In. He also let it crash out for a few days, and I'm wondering, do I really need to, like. Oh, I guess my Pro ran out. Dude, what? Okay. Is it doing anything? Okay, weigh 40 grams. Grind until crisp, but visually grind. Do not grind them. If necessary, sieve out stream. Place loose layer of cotton or. Okay, so the main thing is just the 2 extra filtration steps. All right, it's time to get started. Oh yeah. I think yesterday I started at like 10 a.m. Now I'm starting at 2:30. It's gonna be a late night. I'm gonna have to get the lights out. Okay, but it is how it is. So all right. See, how's this stream doing? Okay, that stream's good. All right. So I think the filter worked pretty well. Okay, so it's time to do some cleanup, and then I'll get the rest of the stuff. Okay, so I need to get the waste, and then I want to zoom out, do the full shot. All right, new gloves, clean all this up. I mean, it's cool. It's cool. All right, so I'm just going to do the thing. Man, I think this ethanol was like pretty expensive though, but it's okay. All right, goggles, and then time to get the sock slit stuff. Okay. Then the waste. Okay. So now the waste container. I'm starting over. I ruined it.
Doing it all over?
Yeah.
All over?
Yeah.
Why?
I didn't get anything. Here, well, you can come look at it.
Okay. Sorry, I'm gonna leave now. I'll be back in an hour.
Yep. All right. So the big part of this is resilience. It is so about resilience. Oh. Let's see here. How do I want to do this? Because I'm gonna do this like right after this. Ooh, this actually might be a huge issue. Hold on. I forgot to grease this joint. Please tell me. Okay, good. I think it's clean. I don't think that this is that much of an issue. I'm just gonna pour it out. Ooh, slippery. I'm just gonna pour it out and do it again. I don't even need to clean. Oh, but I did want to test the pH of it. Still very basic. Okay, so that's man, it's actually amazing how basic it is, even though I didn't even add that much what should I do? Should I just neutralize this? I think I'm just gonna put it in the organic waste. And I'm curious, if I wash this thing. Oh wait. Okay, so this is neutral. Okay, so I'm just gonna put the stuff back for this. I'm gonna start over. Okay, cool. Oh. Okay, but now I'm a pro, so now this is gonna be easy. Okay, so at this point, pretty much everything is clean. Oh, I forgot to get the scale. I always forget the scale. Okay, this thing, I need a weigh boat. I'm just gonna go weigh it and grind it over there. So, yeah. But, how did I have this? This thing is not working for me. Honestly, I think I'm just gonna do this. And then, no, this doesn't work either. Okay, I have to go back to the plank. The plank is so annoying, but it has to be done. I've gone back and forth on filming so many times. Okay, so why that? Because now I can use this how I want. Which is like this. Thank you. Alright, so that's basically it. But alright, I'll set up the condenser in a moment. For the time being, uh, um, okay, I'm gonna grease up everything. Okay, again, burning 250 milliliters of my precious ethanol. Why does that feel less sturdy than it should? Okay, grinding time. So I'm gonna measure 40 grams of this. All right, I'm not gonna show that. It's not worth it. Okay, 40 grams of this. Grind it up. All right. Okay, well, it smells like pepper. Okay, so, oh wait. Okay. So here's what's gonna happen. I need that nice stir rod that I had. Boop. I need to take a break because this is like actually I'll just start it. Okay. Oh. It seems like less than yesterday, but I don't know. Okay, about 245. Stir bar. Stir bar. Okay. Hey Google, set a timer for 2 hours and 15 minutes. What? Bruh. Hey Google, set a timer for 2 hours and 15 minutes. Okay, I haven't checked chat in forever. What is going on in chat? Dude, AI tokens running out sucks. I remember I keep upgrading to Pro because it feels so bad to be in the flow and not have any tokens. They don't like that reflection. What is that? There's one specific shot that I really want to get. It might not happen because I didn't clean this thing properly. Actually, yerba mate extraction would be kind of fun. It seems lighter in color than the last time, actually. Oh, that is just art. Where's my guitar, man? Now I got the main footage that I need. Oh wait, actually wait, there's some more. Need that. Yeah, actually I'm gonna get a little bit of acetone here. Just clean up. It's so mesmerizing, really. I can watch it for hours. I can watch it for hours. You are a cinema. I can watch you forever. Can't I do this? It's getting so much clearer. You know, whatever. It's not clear though, so, you know, I guess I'll just keep going. Because presumably, the total volume in the system is fixed. So any additional color that is taken out of it, if I assume that that color is pure piperine. Piperine. Let me actually check. I think I asked a question about that and I didn't. I think I didn't get an answer. Oh yeah. This will be the third. It's done 2 so far, so that this will be the third, and it's been 45 minutes. All right, 10 cycles, 150 minutes, 2 hours and 30 minutes. All right. Let me see. So we're on. So let's say we're on cycle 3, or cycled 2 times. Okay, that's what I'll. I wish I had a robotic arm that I could maneuver the camera. I put some foil around it. Chet told me not to, but I just want to speed this up. Hot dog. Oh, cool. That definitely sped it up. Condenser's still at 25%, so I say we're good. I say, because I'm about to cycle for the fourth time. I'm at 115. Yeah. Okay, that's the fourth cycle. Actually, has it really only been 3 hours? I guess. Oh, so weird. Okay. Just cycled again. And what is that? That's 5. Okay. Halfway done. Oh, what? Piperine.
Black pepper is one of the most common and widely used spices on earth, to the point that you would probably have a hard time finding a household that doesn't have any. The chemical primarily responsible for black pepper's unique flavor and aroma is called piperine, and today I'm going to extract some directly from black pepper. To get started, I weigh out just about 43 grams of pre-ground black pepper and set it aside. Next, I cram a cotton ball into the bottom of this piece of glassware called a sock slit extractor, which I've never demonstrated before on this channel. Once the cotton is in place, I pour in my black pepper and then put another cotton ball on top. And these two cotton balls are basically taking the place of a piece of glassware called a thimble that's supposed to sit inside of the sock slit extractor. I go ahead and set this aside, and then I pour 150 milliliters of isopropyl alcohol into a 500 milliliter boiling flask that's situated in my heating mantle. At this point, I just need to construct my extraction apparatus, and to do this, I simply connect my sock slit extractor to the boiling flask, and then I connect an Allen condenser above the sock slit extractor. Cold water is circulating through the Allen condenser, and I crank my heating mantle to 100 degrees Celsius. As the isopropyl evaporates, it travels up the leftmost arm of the sock slit extractor and back up to the condenser, where it's immediately condensed back into a liquid and drips onto the black pepper. Over time, the solvent soaks through the pepper and pulls out the piperine along with several other secondary chemicals. As the volume of isopropyl in the sock slit extractor increases, it begins to travel up the secondary cycle map, and this is where things start to get interesting. Here's a diagram of the soxhlet extraction apparatus so you can better understand what I'm talking about. Basically, the idea here is that when the solvent rises to the top of the fin in the secondary arm, it'll create a vacuum which will pull all of the isopropyl through the black pepper and back into the boiling flask. At that point, it will immediately start to evaporate again and condense clean isopropyl back on top of the black pepper. This builds until it triggers the cycle again and the process repeats, which makes this a continuous extraction technique. The cool thing about this process is that due to the fact that black pepper is being continuously rinsed with fresh isopropyl, you can achieve a nearly 100% efficient extraction with a relatively small amount of solvent. This process is also entirely feasible without an expensive soxhlet extractor, and all you need to do is boil the black pepper and isopropyl for a while and then filter the black pepper out. The only real downside to a method like this is that it's going to be a lot more wasteful of solvent, which is only really a problem if you're using expensive solvent or if you're doing extractions all the time. Otherwise, it's totally fine. Anyway, I go ahead and let this cycle run twice, and then just before the cycle triggers a third time, I remove the heating mantle, allow it to cool, and then trigger a third cycle by dripping a bit of isopropyl through the top of the condenser. I then set this up for a standard distillation to boil away as much of the excess isopropyl from my extract as possible. This is something you might typically do with a rotary evaporator if you are extremely wealthy and happen to have one. And it's also typically something you only do with an expensive solvent, not typically isopropyl. Once I collected about 100 milliliters of isopropyl, I cut the heating and set my flask aside to cool. While I'm waiting for it to cool down, I go ahead and dissolve 2 grams of potassium hydroxide in 20 milliliters of isopropyl. And this was a bit tougher than I expected, and I ended up having to heat it a bit on the hot plate to get it to dissolve completely. This alkaline isopropyl solution is then added to my extract, and the idea here is that the hydroxide should react with the majority of the non-piperine chemicals that were extracted. This will saponify most of the fats and oils present, while most of the secondary alkaloids present, besides piperine, should be made insoluble in isopropyl-like stuff. To that end, I stir this for a few minutes and then pass the solution through a cotton ball to remove all the crap that precipitated. This step ideally will leave me with a solution of now water-soluble plant oils and water-insoluble piperine. Now, to actually separate out my piperine, all I need to do is very slowly add ice-cold water to the solution. Immediately upon adding the water, white clouds of piperine form as it crashes out of solution. And this looks pretty cool, so I'm going to stop talking for a moment so you can watch it. As you can see here, I keep adding water until the piperine stops crashing out, and then I pour this into a larger beaker and leave it overnight to allow as much piperine as possible to precipitate out. When I come back the next day, I pass the solution through vacuum filtration to collect my piperine. And even though it looks like a lot got through here, I thought a lot got through here as well and went out of my way to precipitate all the piperine and filtrate, and it really didn't amount to much. It seems the particles that do get through are very, very tiny. With that said, this left me with a yellow slab of crude piperine, which I next added to a crystallization dish and dissolved in a minimal amount of hot isopropyl. I intended to let this cool down slowly.
Dude, what is going on? Is my computer just fried right now? I guess.
But over an hour passed without any changes, so I got bored and left it overnight. When I came back, all of the isopropyl had evaporated, and I was left with these crude and obviously very impure piperine crystals. These crystals felt resinous and kind of tacky, so I'm sure the primary contaminant was oil that had not fully saponified in an earlier step. But I go ahead and weigh this anyway, and I got a crude yield of 1.7 grams, or 3.95% of the initial mass of my black pepper. This is already a very low yield compared to what is supposed to be the piperine content of black pepper, and I blame the 3 gram stuff. Regardless, I then tried to recrystallize this again in an even smaller amount of isopropyl, and this time I did actually get some recrystallization. You can see that absolutely pure piperine crystals are long, slender, and translucent, unlike the opaque crystals I got earlier.
I have to record. Okay, oh yeah, I actually wanted to know. My Nikon D7100, for some reason, like, I try to record, and it only lets me record for 20 minutes. Now, I don't know if that's a cap on the file size or whatever, but is there any way to, like, make sure that I record, like, everything? Or, like, for longer?
Waiting for crystals to form, and I go ahead and pass these through vacuum filtration and desiccated them under vacuum for a few hours. I then weighed them and got a mass of 0.73 grams. According to the internet, black pepper is a lead allegedly 5 to 10% piperine by mass, and this is about 1.7% of my initial mass. So obviously some piperine was lost along the way, as I've never done this before, and a lot of product is always lost in trial and error. With that said, I think I could very reasonably double this number with another attempt, but that still doesn't reach the minimum percentage found in black peppercorns. So I'm going to assume here that the mass of piperine in pre-ground black pepper must be lower than in fresh peppercorns. Obviously, though, this is an assumption, and I'd still need to test it to be sure, but regardless, I'm generally happy with how this went. I really want to get some more use out of this oxalate extractor, so let me know in the comments what you'd like to see me try and extract next. However, there's more you can do with this oxalate extractor than, extractions. This does require you to get a little creative, though, and one thing I discovered on my own that definitely already has been discovered somewhere in the world is using this for esterification reactions. Specifically, I have a few videos coming up where I filled my oxalate extractor with desiccant beads and then performed an esterification while definitely already has been the oxalate extractor than, extractions. This does require you to get a little creative, though, and one thing I discovered on my own that definitely already has been discovered somewhere in the world is using this for esterification reactions. Specifically, I have a few videos coming up where I filled my oxalate extractor with desiccant beads and then performed an esterification while refluxing through the oxalate extractor. This effectively removed water from the reaction mixture and supplanted the use of a Dean Stark trap, which I'm far too cheap to buy. In any case, with that side note,
That's pretty cool. I never thought about using the. I don't really get how that works. That's pretty cool though.
enjoyed this video, and if you'd like to see more like it, consider following me here on YouTube, TikTok, or by becoming a patron. And speaking of patrons, a big thanks as always goes out to my patrons whose generous contributions help fund these projects and allow me to keep this
Oh wait.
channel going. Keep the requests coming, and I'll see you all next time.
Why do they use isopropanol? It says it's soluble in ethanol.
Spices and herbs to the point that you would probably have a hard time finding a household that doesn't have it. The chemical primarily responsible for black pepper's unique flavor and aroma is called piperine, and today I'm going to extract some directly from black pepper. To get started, I weigh out just about 43 grams of pre-ground black pepper and set it aside. Next, I cram a cotton ball into the bottom of this piece of glassware called a sock slit extractor, which I've never demonstrated before on this channel. Once the cotton is in place, I pour in my black pepper and then put another cotton ball on top. And these two cotton balls are basically taking the place of a piece of glassware called a thimble that's supposed to sit inside of the sock slit extractor. I go ahead and set this aside, and then I pour 150 milliliters of isopropyl alcohol into a 500 milliliter boiling flask that's situated in my heating mantle. At this point, I just need to construct my extraction apparatus, and to do this, I simply connect my sock slit extractor to the boiling flask, and then I connect an Allen condenser above the sock slit extractor. Cold water is circulated through the Allen condenser, and I crank my heating mantle to 100 degrees Celsius. As the isopropyl evaporates, it travels up the leftmost arm of the sock slit extractor and back up into the condenser, where it's immediately condensed back into a liquid and drips onto the black pepper. Over time, the solvent soaks through the pepper and pulls out the piperine along with several other secondary chemicals. As the volume of isopropyl in the sock slit extractor increases, it begins to travel up the secondary siphon arm, and this is where things start to get interesting. Here's a diagram of the sock slit extraction apparatus so you can better understand what I'm talking about.
I don't understand why he would think that pre-ground black pepper has low piperine. Piperine.
Have you ever wondered how those tiny black peppercorns, the stars of your spice rack, make their way from the fields to your table? Today we're going on a fascinating journey into the world of pepper production. From lush plantations to careful sorting and grinding, every step is a perfect mix of tradition and innovation. So buckle up for a flavorful adventure, and don't forget to like, subscribe, and comment below with your favorite dish that features pepper. I bet it's Like, subscribe, and comment below with your favorite dish that features pepper. I bet it's spaghetti or a juicy steak, isn't it? Pepper, often called the king of spices, comes from the Piper negro plant, native to India's Malabar coast. Have you ever heard that pepper was once so valuable it was used as currency? Back in the day, Roman soldiers were paid in pepper, and during the Middle Ages, it was even nicknamed black gold. The Piper nigrum plant thrives in hot and humid climates, with temperatures between 75 to 85 degrees Fahrenheit, and annual rainfall of about 100 to 150 inches. Lush tropical regions like India, Vietnam, Indonesia, and Brazil provide the perfect environment for this vine. But how does this
What was that?
humble plant produce the spice we sprinkle on almost everything? Let's dive in. Step 1. Cultivation and growth. The journey begins with the very foundation of pepper production, cultivation. Pepper plants aren't grown from seeds like your backyard tomato plants. Instead, they're propagated from cuttings of healthy parent plants, ensuring strong and disease-resistant growth. These cuttings are treated with rooting hormones and nurtured in nurseries for 2 to 3 months under optimal conditions, shade, consistent weathering, and pest control. When the cuttings are strong enough, they're transplanted into fields with well-drained, nutrient-rich soil. Farmers carefully ensure the soil's pH is between 5.5 and 7, the sweet spot for pepper growth. Support structures, such as wooden poles or even living trees, are installed to give the climbing vines a sturdy framework. Once planted, the vines require regular care. Farmers mulch the soil to retain moisture, enrich it with organic fertilizers, and prune the vines to optimize airflow and sunlight exposure. Protecting the plants from pests and diseases, like foot rot, is crucial for a successful harvest. Pepper vines take 3 to 4 years to mature and produce green drupes. And did you know, the same plant can produce black, white, and green pepper, depending on how the drupes are processed. So, which type of pepper do you use most often? Black, white, or green? Drop your answer in the comments. Step 2. Harvesting. Harvesting pepper is like picking the perfect avocado. Timing is everything. The drupes are ready when they change from green to a slightly reddish hue, signaling peak ripeness. Farmers handpick the clusters since the drupes ripen unevenly. Yes, you heard that right. Handpick. No fancy machines, just hard-working hands and a whole lot of skill. Workers often climb the vines to reach those high clusters, making this process as much a workout as it is a job. The drupes are collected in baskets that allow air circulation to keep them fresh during transport. An acre of pepper plants can yield 600 to 800 pounds of peppercorns per season, depending on the care and environmental conditions. Once harvested, the drupes are promptly transported to processing facilities to prevent fermentation, which could compromise their flavor and aroma. Timeliness at this stage is essential. Nobody wants funky pepper. Step 3. Drying the peppercorns. Now comes the transformation. For black pepper, the freshly picked drupes are balanced in hot water for 5 to 10 minutes. This step cleans the drupes, initiates enzymatic reactions, and softens the outer skin, setting the stage for the signature wrinkled appearance. After blanching, they're spread out in thin layers on mats, concrete floors, or raised platforms to dry under the sun for 7 to 10 days. In consistent sunlight, mechanical dryers take over to ensure precise temperatures between 95 to 120 degrees Fahrenheit. This ensures consistent drying, while preserving the essential oils that give black pepper its bold flavor and aroma. For white pepper, the process is a bit more intricate. Fully ripe red drupes are soaked in water for about a week in a process known as redding. During this time, natural enzymes break down the outer skin, loosening it for easy removal. Once the skins are carefully stripped away, the smooth seeds are dried to produce white pepper. This meticulous process results in a milder, subtler flavor, ideal for dishes where you want to heat of pepper without the dark flecks. Step 4. Cleaning and grading. After drying, the peppercorns go through a serious cleaning regime. Mechanical sifters separate them by size, air blowers get rid of lightweight debris, and magnets pull out any metal bits. It's like boot camp, but for pepper. Then comes grading. Bigger and denser peppercorns are considered the cream of the crop. Ever heard of Telecherry pepper? It's the luxury SUV of peppercorns, known for its bold flavor and size. Telecherry peppercorns must be at least 4.75 millimeters in diameter, and their robust flavor is prized in premium culinary circles. Did you know your favorite steak rub might owe its punch to this premium grade? Fancy, right? Grading isn't just about size. Advanced sorting technologies, like optical sorters equipped with high-resolution cameras, ensure only the finest peppercorns are chosen.
Huh. Ooh.
We have like a plot of radius of gyration. Obviously, this is one of the main metrics you want to put through our backbones by, making sure they're not like long Ulysses and not Ulysses. So you can analyze all that kind of stuff. Then you can also do things like over here, we can plot like the fraction of beta sheets, right? So we want to make sure that we're actually getting diversity in our models. So this structure we have quite a few, not all of these, right? We've got lots of beta sheet structures.
That's 7.
Same thing over here. If we look at helix fraction, there.
Okay, I'm gonna stop it at 8 because I mean, like, it's so light colored now that I can't imagine I'm getting really any more. All right. So what's happening right now is I'm reading the. I'm just gonna do the now red one. So. Okay, so I'm gonna go to the bathroom and then prepare. Hey. Yo, is someone in this chat, bro? Who's in this chat? Who the heck is in this chat? Oh. Hello? Like a drill? Yeah. Yeah, I'm pretty sure. Why? Okay. Where's my water, man? Goggles. Okay. So that's 8 cycles. I feel pretty good about 8 cycles. I'm gonna turn off the heat and get a shot of it cooling down. Okay, heat is off. Oh, should I run it one more time? Because my condenser actually heated up enough that we're losing vapor anyway. So yeah, I guess oh, what am I doing? Okay, since it's so full, I'm gonna turn it back up. Whatever. Okay, so I'm gonna watch it for this last one. Oh, actually, wait. The heat is on. Okay, so I'm just waiting till the very last cycle. Okay. But it's definitely true that my condenser I need to get like a thing of ice for this project. Am I even able to zoom in on this thing? Oh yeah, okay. Oh, what? Is it charging or no? Yeah, I mean, I don't know why I don't just get a cooler and get ice when I'm doing these experiments. Maybe, you know what I'm gonna do? I'm gonna go get some ice. Cause I kinda just wanna try it. Mainly just as a way to switch it up. Wait, actually, do I want to do this? I think I just want to do this. You ever see someone bench 15 pounds wearing a lab coat? I didn't think so. You're stupid. Okay. Okay. So that was hilarious, right? Okay. Back to regularly scheduled programming. So, my feeling is that I'm actually surprised that the condenser failed. I really didn't think it would. Okay, so my feeling is that I want to unplug it quite soon. Oh yeah, the water is warm in here, man. That's crazy. It's like a sauna in here. What the hell? That's crazy. Alright, so I'm gonna... Wow. That's crazy. The water's like 37 degrees. Okay, so I'm gonna unplug the heater. And I'm gonna guess that this thing is timed pretty well. Okay, so wait, now I gotta get the heat off of this thing. So what I think I'm gonna do is actually just... Can this hold? Hold on. Okay. What does that sound? Okay, so it's still that dark orange color, which is good. So now what am I doing? I'm passing it through some cotton. Turn off the heat, allow the apparatus to cool, remove the pepper thimble, inspect the ethanol, and if particles escaped into the flask, which it doesn't seem they did. I mean, the liquid seems extremely clear, actually. So, given that it's so clear, okay, so I need to, uh, I need to go get a cooler. And I need to go get a bag of ice. Okay, so what does that mean? I'm gonna end the phone stream. I feel like that's not even that useful. Okay. I'm just gonna end both. I'm gonna just start it up again. So I'm gonna leave that to cool out